Hello everyone, and welcome to another Tech Tuesday video. So we have decided to change up our format a little bit. So going forward from now, we're going to be having a lot more um, shorter videos. So for today's video, I just want to go through the Flappy Birds project that we were busy with in the previous part of the series. And I'm just going to go through and just show you how I would go about refactoring this whole uh, small project, just making it a lot easier to read, just making some components that we could actually reuse and don't have to do a lot of duplicate work and stuff like that. And since it's also coming to the end of the year, um, we're also just going to tone down the videos a bit while we get our structure ready for the next year, which is going to be pretty big. Um, so yeah, let's get forward. So right now I have the Flappy Birds project open that we finished in the previous video. So there will be links in the description um, so that you guys can check out the video and see how we got up until this point. So yeah. Okay, so before we get started, let's just run this game again and just see what we have already. Okay, cool. So before I started this video, I just went ahead and extracted all of these background images that we used to their own class. I just did this to save a little bit of time since this was the easiest one to extract, and there's not really much going on inside of that class. So yeah, so before we extracted this into a class, we had a lot of code all over the place just with random values um, determining what needs to be done. So I just made this a little bit more dynamic. So I started off by just declaring some constants for the screen size. Now there's just one problem with this with the processing framework. So you'll see that I have the screen size here still hard coded. So unfortunately, with the processing framework, you will have to do that since it can't accept any dynamic variables inside of this size method. So you'll see if we now go and let's just add screen size here, screen X and screen Y, and play this, you'll see it won't work. Immediately breaks out, gives you an legal state exception, and that's because you can't resize this screen dynamically, or at least not through the size method. So unfortunately for right now, we're just going to have to still declare the screen sizes by hard coding them, but that's fine. So now every time we have to update the screen sizes, we can just do it in two places instead of like before we had to add it everywhere in the file. So now I have also, by using this new background image class, which we will go through now, um, reduced the code by quite a lot of lines. So we used to have to duplicate all of the if statements and all of the drawing functions for this specific background images everywhere in the file. So here we used to like move the images. That's not needed anymore. Here we had if statements determining if the image duplicates again at the end of the screen, all of that kind of stuff. But that's not needed anymore. So now what's quite nice is with this background image class that we created now, we can only go ahead and in our setup function, we can instantiate this background image class, give it its variables. I will go through these variables we pass through now in a second. And after we've done this, it'll do the initial drawing of the images. So it'll just paste them onto the screen, and that's exactly what we want them to do. And we can just do that by using these 4 lines of code for 1 line for each image we use. And then in our draw function, we don't have to do a lot of logic and all of that stuff around here, we can just call the render function we have on our background image. And I'll explain this variable now as well. But we can just have this render function called, and then that removes all the logic from this draw function and just abstracts it to the background image class. So you'll see if we run this, it still works exactly the same, and we now just have less lines of code. So that's always good. Okay, so let's just go through this background image class. Okay, so I just created a new file called background image. So this is obviously just going to be the house for any background image that we want to live there. So I just went ahead and created a few variables we need to use inside of this class. So our starting coordinate, that it would be the coordinate where this background image will start its rendering. So let's just stop this game here. That would be, in this case, the sky, it'll be on 0. So if you pass it 0, it'll start at the x position of 0. The duplication coordinate, that is just where you want the second image to start. Since we're using the method of using 2 images and then scrolling them um, at certain speeds for that parallax effect, I just have a duplicate coordinate method variable that you can pass to it to say where you want to start that end image, just in case you don't want it to start at the end of the screen. Maybe you have like 2 images that work differently that you might want to stitch together in the middle, and then you can do a lot more now with it. The other variables I have is the pimage class for that, which is a processing framework class, which is just the actual rendering of the image, or the class that houses the methods to render the image. So you don't pass this through. This is instantiated with the image URL. So the image URL, just the path to whatever asset you're using. The background speed, that would be the speed at which the image moves. The screen X and screen Y, that's just the size of the current screen we're working with. And the height offset you can pass in order to just change the heights of the initial images that you pass through. So I just went ahead and extracted all of those into these variables. Here we just have the constructor. So every time you instantiate it, let's see, so here on line 28, we created a new background image. We passed it a variable of 0, so it'll have a starting coordinate of 0 at the edge of the screen. We pass it screen X, that's the size of the screen we're currently working with, so it'll start at, the second image will start at the end of the screen. And we passed background speed, that's just the speed it goes at. It'll just go at 1 pixel per frame. And the image URL, we pass the image URL, that's just the asset path. And then we just pass the screen sizes, so those variables we declared, the screen sizes, and the height offsets. So we don't have an offset for this for the full background image, so we just pass 0. And we just set all these variables here. And here I have a function called setUpBackground. So whenever you instantiate this class, it calls this setUpBackground method. I just made this a private method since it's never going to be used anywhere else. So here it just loads the image. So this is what I said. It just pastes the image onto the screen. Just static pastes it there. And here we just resize it. So we just use that method of giving it a few extra pixels at the end so that they don't you don't see like a pixel gap between the 2 images. That's the only reason this is here. And then we just gave it a public method that you can access anywhere throughout your code after instantiating. So in this case, on the draw function, we want to render so the draw function gets called each frame. We just want to render this image newly on each frame, which is just going to help us animate the actual image if it needs to be animated. So for this render function, I just passed a boolean called animated. So we do have some static images in the background, like the sky. It never moves. But then we have these other three images, the clouds and the mountains, which do move. So if we want to animate them, we can just pass a true value here, and then it'll use all those speeds and coordinates to just move these images. But if we do pass a false, it'll just be like this sky background and just stay still. It'll never move. So let's go through this function. So if on the first line of this function it just draws the background image at whatever coordinate it is, and then if we passed false on the animated, it'll just stay like that. It'll just continuously render it at the exact same spot. Also the reason we want to also render these static images each frame is just not to cause any like blur effects. So if we just have it statically rendered there, but then render all the other images in front of it constantly over and over and over, and this one stays static, like we just call it once on the setup and never re-render it, it'll just burn the other images in front of it onto its background. So then you'll just get these weird blur effects, which is not really nice. So yeah, okay, so it goes in here, and if you have an animated, it'll then draw the duplicate image. So obviously if you have a static image, you don't want to draw the duplicate image as well. That'll just be unnecessary. And then we just go ahead and each frame, or well, each time this is called, reduce the starting coordinate by the speed, and as well as the duplicate coordinate. This gives that animated effect of it moving. And then we just have those bunch of if statements that we had in the normal file. We have now moved these into just being two separate if statements, so we don't have like 6 or 8 anymore. These are all just in this render function. So only thing that's happening here is it says if the starting coordinate is less than the negative amount of the screen size. So if it moved a full screen away, just reset that starting coordinate to render the image at the back again. And then we just do the exact same for our duplicate image. So immediately, looking at this, you can see it's a lot, easier to read now and a lot easier to use now. We don't have all of these p-image background weird variables that we're moving around and doing anything with. We just have straight up this, we just call our background image class, pass it what we want it to have, and then it'll do everything in the background for us. And then same as the draw function, we can just call its rendering function and it will render everything for us the way we want. So yeah, that would be just the refactoring of the actual background images. Okay, so now that we went through the background images class, I am going to walk you guys through how we are going to extract the pipes class. Again, just to save some time, I already did this in the background, so I'm just going to walk you through the class that I created. So immediately you can already see now, in order to instantiate the pipes for our game, it's a lot easier. We don't have all those variables that houses all those different image URLs and spacing and all of that stuff. That's all been extracted into our class that we're going to use. And in the setup function, you can see as well, we don't have to load all those images. We can just call our pipes class, give it our images, the amount of pipes that we want to be shown, and then just our screen sizes. So it's a very simple way to initialize them. And same as for our background images, now we can just render our pipes. So the only thing with our pipes is they also contain our collision detection, because they are objects that can be collided with. So we just pass to our render function what the current height of our bird is, so that it can detect if the bird has actually collided with one of the pipes. So again, now we just call this pipes render method. All of these randomized values we used, they're all gone now. And here at the bottom, you'll see that there's a bunch of its if statements removed now as well. We don't need all of that. So yeah, it's a lot more cleaner. So let's go through this class. Okay, so here we have our pipes class. Let's just walk through the variables that we give it. We just give it our image up and our image down. So that's just the different assets to make it look nice. Then we also pass the amount of pipes we want on screen. So that, I mean, if you increase this value, they'll just generate closer to each other, which creates a more difficult game. And this will come into play in the next video once we add game difficulty and just the finishing touches. Then we also just pass the screen sizes, and then some variables that we use just inside of this class that's private and not going to be used inside of our actual game is the gap differences. So this is just how spaced all of these pipes are from each other. And we have our pipe tops. This is just the Y position for our pipes facing down, and the bottom one, same thing, just for the pipes facing to the top. And then we just have our P image arrays. So this is just to house the actual assets, and yeah, okay, our screen sizes. So in our constructor, same for the background, I just created a private method for setting up the pipes. So let's go through that. So if we go through our setup pipe method, what happens now is we just instantiate these arrays with the amount of pipes that we're going to use, and that's how we're going to determine which pipe that we're working with. Then inside of that, I just created a for loop, which is simple enough. For the spacing between the actual pipes, you can play around with this. This can be however you want it. I just found this to work for me for the amount of pipes that I use. Again, you can use any type of formula you want to work out the spacing between your pipes. For me, I just went, the difference would be wherever it starts plus um, half of the screen. So they'll always be spaced. In this case, if I have a screen size of 600, they'll always be spaced 300 pixels from each other. So technically, you'll only see like 2 and a bit pipes at a time. But again, you can play around with these values and just change them however you want. For our pipe positionings at the top, I just made them a random value of half the screen's height, and then just give it a threshold of 100. Again, you can play around with these values. Nice thing now is you can just go to your pipe class and play around with these values here, and you don't have to do it for each and every one of your pipes. So that's pretty nice. For the bottom ones, I really didn't really make these dynamic. You'll see now when I play the game again. So they're kind of like static. Um, at the bottom, you can randomize these values the exact same way here, like just inverse, and then that'll fix those pipes being static. We'll also do this in the next video. So we have to for the game difficulty, but for now I just kept it like this. I don't really have a need to change these. And then okay, here we just load our images again, same as in the previous video. Now we just get the index of the array and then just give it a asset. And for the resizing, again, we just resize these to fit whatever size we want our pipes to be. So that's also simple enough. Now we just don't have to duplicate these resizes every single time. And now going to our render method. So this method again gets called each frame, or however many times you want it to get called. So in this case, we have our render method with a variable passed through, which is the current height of the bird, or at least in this case, we only need the height to determine what our collision would be. So this is just the positioning of what our bird is in that current state. Again, inside here, we want to do these changes for each and every single pipe we have in our game. So we just loop through them again, and here we just render these pipes. So I'm just rendering the pipe at whatever index it is, that asset, and then this gap def, this would just be its X position. So this is wherever its X position is. So if you have more pipes, it'll be determined with this formula. So in this case, this one will start at the end of the screen. The next one will start 300 pixels from that. Next one, 300 pixels from that, and so on and so on. So you can just tweak this formula, and then that'll change those differences in between. And for the pipe top, this is just the top positioning of the pipe. This is also another reason why it's static. You have to change this with this pipe bottom value in order to make the bottom pipe move up and down as well. But that's easy to do. You can just use the same formula for here as well. So for the bottom pipe rendering, we just have the bottom pipe image, same X position, but now we just have a little calculation for the pipe top and the bottom. This is just so that they don't collide with each other. And on the next line here, we just gave it a set speed, because this will also be changed with our game difficulty that we're going to be setting in the next video. So in this case, it'll just move at a speed of 2.8 pixels per frame to the left. So that's all that this does. And here is our collision detection. So I did explain this. I'm not going to go through this whole collision detection again. In this video, because I did do it in the previous one. So basically all that's happening here is just using that bird height to detect if the bird has crossed that rectangle that we have for a pipe. So if it does do that with this formula right here, it'll stop the game. And then this next statement is basically just detecting if the pipe has gone off screen, so that it just renders it back again at the rightmost side of the screen. So yeah, we did all of this. This is still a lot less code than we had for the pipes on our actual game. A lot less code, so it looks a lot nicer now. Once we finalize the bird as well, it'll just look very clean. But yeah, that's the how I went about extracting these pipes. Again, this is not the only way you can do it. There's a lot of ways you can do it, but this just worked for me. So if you play the game, you'll see it still works the exact same way. Like I said, the bottom pipes, they are currently static, don't move, but that's going to change in the next video for the actual game difficulty. But the gaps in between the pipes, they do actually change, whenever they're rendered differently. So yeah, and the collision detection still works. All of that is fine. Cool. Yeah, so let's get on to the next section. Okay, so now that we have done the pipes, we can move on to our final section, which would be just refactoring the actual Flappy Bird. So again, I already did all of this now, and this one was like a lot less complicated, so there's not too much to explain about it really. So I'll just go through what I did, and then show you guys the results. So immediately you can now see our page has been fully refactored. So for our bird, we don't have all the variables set, we just have our bird object, and we instantiate it with the height of the bird, or well, the size, its starting point. This is what this is, the y-axis point that it starts at. You can set this to anything. And then in our draw function, we don't have all of this clutter here anymore, or any extra functions underneath. This is just our game board now. We just have our bird that's being rendered each frame, and it handles all sorry about that, it handles all of the animations and everything for us. So let's go to this bird class. Okay, so in the bird class, you can immediately see the variables that we're using is just, again, the p image, that's just the asset. In this case, we're not passing through strings for the assets because our bird will always just be the same. There's no reason for changing it. Like for the pipes in the backgrounds, you would always want to, maybe use some different backgrounds, stuff like that. For the pipes, you would like to use some different assets. Maybe not even use pipes. Use like some stone columns or spikes or I don't know, whatever you want. But our bird will always just be the same. So I'm not passing through anything for our bird specifically because it will always just be consistent. The only thing I'm passing through is its starting point. So this is this bird height. Then we just have all of our stuff extracted from the previous session, which is the speeds that it goes when it's falling, speed that it goes when it's flying up, the threshold, so speed it can't go faster than 4 pixels per frame. And then this is just some of our animation work we did. So our frame counter and the state that the bird is in, if it's flapping its wings or not. Then we have just the normal state, which is if it's not flapping at all. And then here we have our constructor. So as you can see, we're just passing the starting point of the bird. This would be the only variable that can be accessible from outside, since we need to send it to our pipe to detect collisions. So we made this a public variable, so we can, if we look at our game board, you can see that every time the pipes render, we now send it the bird's height, just to detect if the game should stop or not. So in our setup function, that's very simple. We're literally just loading the asset for the bird. There's nothing special about it. Then we just created our rendering function again, and again in here nothing special. Everything that we did in the previous session was just literally pulled over to this render function, and the same goes for these methods that we use: the cycling of the animations, the resetting the bird's animation states. All of this has just been moved into this new function, I mean this new class rather, and they've all just been made private since we don't want it to be used from the outside of the class. So yeah, now you can just call the render method and it will paste this bird onto your scene, which is nice because now you can actually go ahead and just take this class, and if you want to work on something else but still want to just use the same bird with its same functionality, you can now just use this class inside of another processing project that you have, and it will work exactly like it should without any issues. Same with the pipes and same for the backgrounds. So if you don't want to use any of the stuff in this project and maybe just want to use these nice background classes for parallax effects, you can do that, and then you can add that to your scenes. And they're all dynamic, so you can just play around the values and they should still work. But yeah, that's basically the refactoring for the bird. There's not really much to it, so it's not really that nice to explain, but it's always nice to actually refactor all of your work and get it into a state where it's very easily reusable. So this will all come into play now in the next video we create, where we add the game difficulties, where our game difficulty will be a singleton service, so it'll be accessible through all of our classes, and then that's how we can determine every time you move past a pipe or something like that, that it will update the game difficulty, and then just update some speeds here and there, or some gaps will get smaller, all of that stuff, and it will also give us our scoring system, telling us how many pipes we've traversed. So yeah, all of that will be in the next video, and then the one following that will then actually be our machine learning video. So where we let the computer actually teach the bird how to play the game itself. So that's gonna be quite fun, and this refactoring actually plays a key role in that, since we do want all of our classes abstracted and create helper methods inside of those specific classes to teach the computer to actually play the game itself. So yeah, that's all gonna be in our next videos. This was just a short, simple refactoring explanation, and yeah. So thank you guys for watching. Hopefully you can take something from this video. I know it's a bit different. There was not really a lot of coding going on, just some explanations, but yeah, hopefully you find this useful, and see you guys in the next one. Bye.